Okay, so we are checking sound. Seems that my camera did. Am I even moving? Yes. Okay. Sound check. Yes, seems to work, right? Awesome. And now they're gonna hear that looping, forever. Fantastic. Thank you for that. Okay, so it's 2 minutes left, so we just relax for a little bit. So, but yeah. Yeah, it takes a while. So it's like 15 seconds delay or something like that between the live and or the stream. I can post the slides. Slides. Well, since there is some delay, maybe I can start now. And then it will start right on time for the Okay, so welcome to this part of the software testing course. And I'm Daniel, and we're going to talk about unit testing. And we're also going to talk about test-driven development a little bit, but that is probably tomorrow. So, or it is going to be tomorrow. So the sort of schedule or the content of this lecture is that we're going to talk about unit testing as concept, and we're also going to look at some examples of that. And some of these examples are a bit old, but it should be fine. And we're going to talk about unit testing more specifically, like XUnit frameworks, which JUnit and different testing frameworks that are all a part of this. But we're going to keep it a bit more general so that the things that you learn is also going to be valid in a couple of years or so. Yeah. So some slides have some old stuff on them, but that is how life is. This field is changing really rapidly. And then we're probably at some point here gonna run out of time and continue tomorrow then. So the agile testing and test-driven development is going to be tomorrow, I think. So unit testing, we're going to talk about manual, automated, and framework. So just to get started, we do some repetition from last lecture, where we talked about test cases and what a test case is consisted of, and also the different goals we have of test cases. And the general goal we have is that we want to be able to test our application, right? So we want testability, and testability could be divided into controllability and observability. So controllability was that, we need to run specific part of the code, and if this specific part had the fault, or what we also call a bug, so we need to run that code, right? We want that code to infect the state so that we get error state. And then we want the error state to propagate, so it should, move up to the surface of the application where we can observe it. And that it was the observability, right? So if we have a lot of program state hidden down in the application, that is quite hard to observe. And unit testing specifically is to increase testability by adding controllability features and adding observation features. So we had other goals of test cases. We wanted it to be accurate so that we can, pinpoint the specific part of the code that contains the error, or no, not the error, fault or the bug, right? So in order to do that, we want to run just small parts of the code instead of running the entire thing. We don't be too confused on this. If we were smoke testing, we wanted to run all the code, right, as much as possible, because we want to see, is there smoke coming up anywhere? But this is different, right? So when we unit test, we just want to run a little bit piece of the code, or we exercise that piece of the code, and that is in order to pinpoint the location. So if we run just a little bit of code, we just need to do a little bit of debugging to remove that fault and replace it with more correct code. So this is, perfect for unit testing, right? We also want traceability, right? So we want to understand what part of code was causing this. It's sort of the same thing, right? And when we have badly written code, that code is hard to do this with. So testability, or in order to get accurate pinpointing of faults, we also need to be able to run just a little piece of the code. So we're going to talk in the end of this lecture on what kinds of code is harder to test than other kinds of code. And this is, relevant for your first assignment also. So enough with the repetition. Let's just go dive into unit testing. So unit testing is testing a unit. And a unit can be, we define what that unit is. So it could be a single method or a single function. When I write method, I usually include both functions and methods. And a method, for me at least, is defined as a method that hangs onto an object, while a function is something standalone without an object, without this, so to speak. But a unit itself could be a method or a function. It could be a class. It could be a component. The general idea is that we say that, I'm only going to test this piece of the code in isolation from the rest of the code. If the code is badly written so that it's so-called spaghetti code, which means that it, within a function, we call some other function, which calls another function, which calls back a function at me, and then something like that. That is super hard to test things in isolation because we run a lot of code. Okay, so unit testing. Normally, people think of unit testing as unit testing frameworks and whatever I do with unit testing framework, which is not really true here, or it's not how I want to define it. So I want to define unit testing as, we're only testing this unit. But you could use a unit testing framework to test the system, the entire thing, right? The client, the backend, the databases, everything included in the system. But this is not what I mean with this. So we can do it manually, and we have some code that we're going to test. And this code is just a getMax function. It is in the class myMath, in the package math, and this getMax takes an array of integers, and it should return the highest integer in the array. So very simple code, right? And as usual, in order to create bugs in such simple code, we, there might be quite stupid bugs. But actually, most faults are, we do some error in thought or, in action, and then suddenly we have a bug. So it's not a completely, but we're going to run a manual test first and a manual unit test. So I've written just a piece of code, and it's not that, hard, but I create an instance of the system under test. I also create some stuff in order to manually test this. And I've created, a normal application. So I just create an instance of this, and then I run that instance. And within this run, I do stuff, right? I print something so that we can test this manually. So I say that enter an integer array separated by spaces, and then we read from the console, we get an integer array. Of course, this reading from the console, perhaps people are not inputting numbers, and then we get some error or some exception happening. And I don't really care about those errors or those faults, I mean, or those problems, because we are working in manually testing a piece of code, and it's not this manual test code that we're really interested in. But exactly like with test cases described last lecture, we are exercising the system under test by calling the method that we want to test. So we're going to test getMax, and then we have this integer array, which is the input. And then we just output the actual, and we're manually going to observe this. So let's see if I can run this code, and we're going to change this one into that one, and then we have some errors, and then we run that code. Enter an integer array separated by spaces, and then we just test it, right? So suggestions for input. So I'm just gonna write 1, and the max was 1 in that array. Great, it works. No bugs. So I want you to write in the thread different inputs that I can manually test this with. Since there are some delays, you can take 1 or 2 from the audience in the classroom if you want to. So I get a -10, and it inputs 0. Oh my God, the first suggested test case actually produces a fault, right? I get another one. Let's see if we can find out more. 0 and 10. Oh, the max was 10. So it worked. It didn't work with -10, but it worked with this one. So I'm getting another one from Alexandro, and let's see if I can input those. And it seemed to work with that also, right? But we have something that happens with negative numbers. So let's try -10 and 0. Thank you for that. And the max was 0. So which was correct, right? So right now we have one failure, one observed failure, this one. So remember that we can have failures. We can have stuff happening on the screen that we don't observe. Let's see if I got the vocabulary correct also. But yeah. Any more suggestions that could dive deeper into this? Maybe we just move on with the lecture. We know that now there is some fault in this code, at least. Okay. So let's see if we can go back. So it can be automated. So we can do manual, not manual testing anymore. We just automate it instead, right? So let's see if I created I call it a naive automated testing application. We're just going to look at it, how it looks like. So it's, again, a main method, and then I create an instance of the system under test. I create some inputs. We can see that 1, 2, 4, 2, and the expected output, exactly like normal test cases. And then I exercise the system under test and get an actual. And then I compare the expected with the actual, and then I write with a print line, test succeeded and test failed. So the difference now is that we no longer manually decide that output was correct or not. We have encoded the Oracle decision as an if statement, right? And then I can, copy paste the same code again, and I have some different input, and again, I have some different input and different. It's actually the same output all the time, right? But let's see if we can run that code. And this, and build, and that, and save, and some error messages, and then we go to the terminal again, and we run. Yeah, 3 tests succeeded, right? So the interesting thing here is that if we look at this naive automated testing application, we see that I have copy-pasted stuff. the only thing that really changes is the input. We have this if statement and the print lines over and over again. And you probably heard about the dry principle. Do not repeat yourself, which means that we want to remove that duplication. So that sort of removal of duplication is important for us. We refactor our code, we rewrite our code so that it does sort of the same thing, but more efficiently code-wise. So we have less code, and that is one of the jobs of a unit testing framework. But before we go into that, I just want to start with a random testing instead. So just to see that I'm following the script, we go back to that. So I have not run the random testing. Let's see if that works. So the random testing looks like this. Creates an instance of the system under test. It creates a random instance. It has a couple of statistics, right? So how many successes, how many fails, how many errors do we have? How many tries are we going to do? How big should the array, the input array, be at maximum? And then we have some, output, and then we run for 100 times this for loop, and then we create how many inputs are we going to have. We create an array of input of that size. We start with an expected value, but right now I set it to the minimum expected value. And the interesting thing here is that if I create my inputs, and while I randomize the inputs, I also calculate the expected value. And this is sort of something that is interesting, that in order to test an implementation that is unknown to us, we may create another implementation of it and see if these two implementations are the same. So testing could also be used in order to, for instance, check if a more efficient algorithm is also correct. So perhaps we have a simple algorithm that we know is correct. It's simple so that we can easily implement it, like this one, right? So it's if the input is bigger than the expected output, I always remember the biggest expected output. So it's pretty simple stuff. But perhaps there are more complicated ways of doing this. When it comes to sorting algorithms, we have this really, really simple sorting algorithm like insert sort, and then we have these really, really complex algorithms. For search algorithm, it's the same, right? And for some algorithms, perhaps we can make a simple one that runs on one thread, and then we can make a complex one that divides work between different processor cores and multi-threaded stuff, complicated synchronization mechanisms and stuff like that. So we could create a model, and then we compare the system with the model. Okay, and then we start running these, and I exercise the system with some input, and then we get an actual, and then I compare these, and then I count how many successes and fails there are, and then I fetch also if exceptions happen and errors. And actually, this particular code that we had, let's see if I can find it without showcasing the bug. Yeah, it throws wrong input exception. I don't tell you why input can be wrong, but if I'm asking for a max of a number of an array, and I don't have any numbers in the array, so it should throw wrong input exception if the array is empty. So it's not defined the max of an empty array, so I use an exception there. Okay, so random testing is going to do that, and let's see if we can run it. And let's do this one, save that. A number of error messages shows up, and then I go back to this one, and let's run it. Now it ran. Oh my God, the array is super large. So the interesting thing here is that I create an array that is, billions of items. It's so big. I don't think that we want to wait for that because that it's going to take forever. So I'm just going to make sure that I think this is the maximum size of an array in Java. So let's say that we have 100 arrays of 100 max size instead. I mean, that is more reasonable. And we can see that we did 100 tests. We got 96 successes, 1 fail, and 3 errors. So the case where we get error is when we have a, I guess, when we have a 0 element array, and we also get 1 fail. So which means that the reliability for a random sampling of the input space of this is 96%. So according to the definition of reliability we had. If I run this again, I'm going to get perhaps the same result. Actually, I got 2 fails this time, and I got 2 errors. Every time I run this, it's random, right? And the more I can run this, 1,000 times instead, and perhaps I want to speed things up, and I change the array size to 10 items, and suddenly I get 80% random input instead, or reliability. And every time I run this, so if I have this kind of construct, and I'm just looking for bugs, or if I'm doing smoke testing or random testing, I can actually, if I have a model of the system that I know is correct, I can compare the system to the model, and we can, fetch bugs just using time. So let's run this 10,000 times, or 100,000 times, or 1,000,000 times, and I run that and I just let it go, right? So this random testing, okay. But random testing normally for me means that I don't do that as unit testing. Usually I just did it, right? But I'm doing other things as unit testing. So we can see that when we ran it 1,000,000 times, we got a lot of fails, but we still got a lot of successes. So it seems that around 80% of randomized input still correct with, right? The interesting thing was that for every case except one that we inputted, we got the correct answer. So there are still things that we don't understand. Perhaps you can still post interesting inputs. But let's go to. We can also use an automated framework like XUnit, and with XUnit, I mean JUnit and stuff like that. So I get a comment. Random testing to me always seems like an inefficient approach that you only use because you can't figure out how elegantly probe the system under test for weaknesses. So sure, but it's it's sort of using time. It's sort of like brute force hacking, where I'm just gonna test every password. It's sort of the same kind of thing. So it makes sense if I have a very complicated system, and we also have some good definition on what is right or what is wrong. Or when you have a simple algorithm and you want to compare it with a more complex algorithm. So, and these tests were written a couple of years ago with another version of JUnit. So don't take it as the fantastic truth. But let's look at the JUnit test for this. So I have a private instance, or it's not an instance, it's a reference to my map object. I call that system under test. I also, defined an expected highest number that I always use, the 2, right? And then these are only to save lines of code in the tests. Then I have a before each, which is a setup method that runs before each test case. So you can see that the setup of the creating a new object of the system under test class is done before each test, and then we run the should return the last highest value, and it conforms with the naming standard that I also want you to follow, but that is not followed by the code that you got in the first lab. And then I defined an input, and you can see I assert the highest here, which is a method that I've created myself. And the assert highest is the helper function, so that I can save lines of code. So if you're sort of checking, or when you check or when you assert, you need to do a couple of things. So you can see here, I input this, I call the get max, and then I assert equals between the expected and the actual. So sometimes we can save lines of code, and I want you to work with your code so that your tests also become elegant. So then I have a couple of test cases with different input, and essentially they are just defining input. So 1 and 2, 2 and 1, and you can see that I named these, and I try to abstract the actual input or the specific inputs, and I also try to abstract the output. So I call it should return the last highest value, which means that the highest value is last in the array for me, right? And this one should return the first highest value, and the highest value is first in the array. Should return the third highest value, and here I also use -1, but I sort of didn't include that. When using a random testing, should we use a predeterministic seed so that we can reproduce tests? I think that is a good idea, but we might want to make sure that if we didn't find any bugs, that we run different tests the next time. So perhaps you output the seed so that you can have that as an input into your test system instead. And I also have a test case: should something when input is empty, should throw exception, should throw input is empty. And then we run these tests, and I want to run them here in and all tests succeeded. So I didn't find the bugs with this either, but we could find them. So anyone has any idea of what the bug could be? We have a clue, right? The Alija said -10, and so let's do that. Let's copy this one. Should return negative, and all should return negative. I think that is. And then let's try -10. And I actually need to have another expected value for this one, right? This actually messes up everything with the expected. So I'm actually going to do it like this instead. Expected and assert highest. And I'm not sure. I'm going to do it like this, I think. I'm messing up everything, but that is fine. Because it seems that we want to have different expected values. And that comes in that and works like that. And then I can just remove this one. And this one is going to be -10. And oh, yeah, it needs a typo. Too much JavaScript. So now I've changed the customize assert method. I've also created a new test case, and let's run that one and see what happens. Yes, it fails. So we know now that it returns 0. And I mean, whenever I have a test case, I can start debugging my code, and I can run the code, and I can look at it. So let's reveal the bug, and let's look at it just so that you can, sleep tonight. So we can see that the bug was here. I, went through all the items in it, but I started with 0, right? So it could be. So let's see if this is still in my. Yeah. So it should instead have the first item in this array as the starting point, right? So if the first item is no, actually that won't work. We should have like the max value should always be the lowest integer, right? Integer mean value, because every integer in the array is going to be bigger than that or that. And this one should succeed. Yes. And we can rerun all the test cases, which is called regression testing, when I rerun all the test cases again. And it took just a second or two, and suddenly my confidence in that I'm doing the correct thing is increased. Okay, so that was unit testing and, 4 different ways of working with this. So, okay, now we've done that. What did we gain? We gained succeeds, and we gain failures, and we get exceptions and crashes and stuff like that. Every different output from a test case is useful. The least useful thing, often, but not always, is that a test succeeds. Because then we know that for this particular specific input, the code worked as intended, right? So the expected was the same as the actual. If the test failed, that is a success for us as testers, because now we get a clue on the bug. And it can fail in different ways, right? The code could provide an unexpected output. This means that a fault was reached. It infected the state into an error state that propagated to an assert in the end, right? The assert was detected a failure, so we have an observed failure. We could, still not look at the test result, but we can have mechanisms in, our build pipeline so that we don't release code into the working if we have a failed test. Tests can also fail due to crashes. We have a divide by 0 or something like that, or do something illegal to the interpreter or to the Windows or the operating system or something like that. We can get an error, or we can also reach an in-code assert. I briefly mentioned that, I think, earlier, that we could have asserts in the code also. It could fail due to an exception. I mean, exceptions could also be, they could also be intentional, of course, but sometimes we have unintentional exceptions. So all results have value and serves as feedback to the developers. So, I mean, the successful ones, I said those were the least valuable because they don't initiate an action themselves. They are just clues that, oh, it worked for this array with, positive numbers in it, but it didn't work with the negative numbers in it. Or when everything was negative, it didn't work, right? So I needed to do some thinking, and the succeeding ones can help me in the thinking. It works for this, but doesn't work for this. So we're collecting clues. But things are never simple. So I think this one is super important for the first assignment, because you know that there are faults in the code that you got, which means that in order to have good tests that are actually telling you the truth, where you can, use this information, you need to know also that your test is good. So a test case can be wrong. And I mean, what if I input this into so let's just look at it. And we input an array with 251, 618, 396. And the expected is 1255, which is wrong, because I intentionally made it wrong, right? But I mean, I've also tried to make it something. So please calculate the expected value for me. And not on, using a calculator or something like that. Just and maybe some of you thinks that, oh, I hate math, and I'm actually going to disturb you a little bit by talking at the same time, because when we develop code, there are often disturbances. So, I mean, it looks right to me when I just, 400 plus 600 plus 200 looks like okay, right? It should be around that, but it isn't. So it is wrong, and I intentionally made it a little bit hard to look up. It's not too hard, right? It's on the edge of what I would do just with my head, right? So let's not do that. Let's make simpler input, because simple input means that it's simple for us to calculate that. So try, whenever you do input, always try to reduce the complexity. We often start with complex input because we take whatever comes up into our mind, and we input long strings and stuff like that. But when we input long strings or high numbers or stuff like that, and when we don't do that by intention, we should simplify that input. So use shorter strings, simpler strings. So instead of having this beta tester string, let's just have B. If you have a small number, it's going to be a simpler calculation. So look at the input in the bottom of the screen. It's 111. Super easy. Didn't take me a second to think that that's free, right? It could be as good as the other input in detecting bugs. It might not be if you're looking for bugs that only occur with big numbers. So there is a difference here. But if I'm looking for bugs that occur with big numbers, perhaps I should have 1,000, 1,000, 1,000, and the expected is 3,000 or something like that. So unless you intend to test specific input for some specific reason, always simplify. And I want you to, when you simplify, you can use the abstract naming as a way of doing that. But yeah, before we change slide, the simplifications are also needed in order to make it easier for the programmer that is going to debug the code using the test case. Because if I have like an array and I have we had 2 billion items in the array in the random examples when we started. If the bug we created or reached a bug and we started to debug that, we're going to have a huge array that is going to be difficult to debug on. Perhaps we're going to step through the code in the debugger over and over again. It's so shorter arrays if possible, shorter input, short strings, short names, whatever, as short as possible to make it simple, and also in order to debug this. So if I have 3 inputs in the array, maybe there is a loop that I only need to step through 3 times. So yeah. Okay, so we've seen all of these things. I just want to mention this name again. I said it, but just wanted it written somewhere, right? So when we ran the code, I call that exercise the system under test. So it's like we're putting it to the test. We exercise it, and then the assert is sort of an if statement, right? Okay, so for int max, we've looked at different inputs that could be reasonable, and I'm just going to show that, this was not very visible, but the number of combination for max is super big, right? So an array in Java could be 2 to the power of 32 minus 5 items in an array. And then, and then we have 2 to the 32 options in each of those positions, which means that we get massive combinations. So we can never really test all of these in our lifetime. I'm sorry, unless we get some weird new computers that can do everything. But even with a supercomputer, this will take the lifetime of the universe to calculate. So we need to come up with good test cases. I'm just giving some examples here. I'm just going to talk about how I think here. So in this case, I just was thinking about stuff that we could test. So 1, 2, 3, 4, and then 4 was the last item in this. Perhaps we should simplify this so we only have 1 and 2. Because if I'm going to check the last item. And you did see that when I looked at the code, I've already done that. And then we have an array that goes in the other direction. Perhaps that is also a good thing to try out, just to make sure that indexes and stuff like that perhaps start with 0. And then I just have 1 item. Then I have just negative items. And then I have a 0 and a negative item. And then I have a negative item and 0. Because, around 0 stuff happens. Perhaps there is a less than or equal that is wrong. And then I have the positive variant of that. And then I have an empty array. And those test cases together, I think, would probably find most of the buggy implementations here. We still might have stuff that has to do with, integer math or stuff like that I didn't think about. So instead of testing the entire input domain, I try to solve the test selection problem, which means that I try to find test cases that, is as good as exhaustive testing. And there are different strategies for this, and we're going to look into those in future. Exhaustive testing, yeah. So, and I think we just start a little bit with test automation here. Now, we learned that, okay, there are testing frameworks like JUnit, but what are they for? And one of the reasons is that we want to have executable specifications. So you already learned that you can write requirements, right? And you've got a number of different ways of writing requirements. And some requirements are like user stories. And some requirements are like, okay, when this particular function is called, it should return the maximum number in the array. But we can express that sort of with test cases instead. We can have a number of test cases, and we could name these test cases. So let's look at the naming of the test cases here. Should return negative, should return the last highest value, should return the first highest value, should return the third highest value, and should throw when input is empty. Stuff like that. That together, those words, so to speak, is my executable specification. And we want to have dry. We also talked about that, which means that if I have a specification that is separated from the code, it means that the code is also a version of the specification, so to speak. And those versions could, go apart. But by having automated tests and by, writing these down as test cases, we can have one specification, so to speak. So there are a number of different, testing framework, like more higher level abstractions of this. When you write a BDD test, for instance, you sort of write your test as if they were sort of use cases. So we name test suites and test, and you're already seeing the test naming strategy that I have, that should, and then we say the expected abstracted behavior, and then we say when or for, and then we say the abstracted input. For example, max should throw exception for empty array. We also want the test to precisely point to the error. This was the accuracy. Test as little as possible of the code. If there are if statements, don't go into both paths of the if statement, just go into one of them. So we test less code. So we have less code. If we find a fault, we have less code to debug. We want quick regression testing. If it takes time to run the test cases, we won't run them as often. Every, time is super valuable for us. We as developer cost a lot of money. So the quicker we run them, the better. And I would say the limit is around, I want to have them super fast. I want to have them, let's just see, 1, 2, 3 seconds. I actually thought that was slow. It took me too long. I want to have it faster, because if it's faster, I can run it, as, almost as if I save something, right? Control S. Maybe I should run the test with, a shortcut. If it's that fast, if it just takes a second, then I can just, Control T or something like that, and then I know that it still works. The more you run it, the better. The more you rely on it, the better test suites you have. So the speed of a test suite is an important factor. And I have a couple of examples on later slides on this. We want to get confidence that the code works. So we should strive for high coverage, I call that, which means that much of the code is actually under test. So what if, let's say that, well, let's go to this one. Let's just, oh my God, now the code works for all of these. So I'm just gonna comment them out. I comment out all the test cases. I run it I actually commented out too much code, right? Or something like that. I got a bug. It doesn't really matter. But maybe I can, speed it up by running less tests. But my confidence in the code is not as big anymore because I don't do good enough tests anymore. And we could have, so we want to have great confidence, which means that we want to have a lot of tests. Oftentimes it is like this, that some developers create test cases, perhaps in the beginning. And then we start to feel the burden of these test cases when we maintain the code. And it takes time to transform these test cases into better test cases. And maybe we also think that it feels like a failure when we get a failure. Perhaps you've also felt this, you ran the compiler, you get a syntax error, and you get frustrated from that syntax error. This is a beginner's mistake. When I get an error or a failing test cases, I'm actually happy, except that my feelings are not happy because I still get frustrated that I didn't get it right. But it's actually important feedback to me. And we should not, put the lid on and just remove the test cases. But this happens, and I've also done it myself. Okay, so yeah, so when we have test automation, we want to have high coverage. We want to get the confidence. Oh, the test ran, I'm safe. That is the idea, right? And then we also want to make sure, in order to get that, we want to have strong tests. And you actually, if you started with the first assignment and started with the sum, you've actually seen that tests can, they can pass even if there are faults in them, in the implementation, right? So not all test cases detect all bugs, which means that some test cases are actually better at detecting bugs. So I'm just going to show sort of a mistake that students do before we take a break now. So let's look at the bottom line here. It doesn't follow your syntax for JUnit, but we assert that the type of an actual is the expected value, which is a string, right? So let's imagine that we have a function that returns a string, and we just check that, oh yeah, it came a string. All we know that when we ran that test is that we got a return value of a specific type. Any string works, right? So any bug that does not return a string, we catch. But any bug that returns a string still, but the wrong string, we don't catch. So let's replace that with the test case where we assert that the specific return string is candy instead, like a string candy. I was hungry and I got candy when I wrote this slide, so that is why it's candy. It was chocolate, it was good. Okay, this particular test case is better than the test case that asserts type, because if it's the wrong type, we're going to get an error. If it's the correct type, we're going to check that the output is exactly candy for this input. So it will catch all bugs catched by the first test, because we can't have a string and compare it with candy, right? And it also catches more bugs. So some test cases are stronger than others. So the idea, and something that I want to give you here, is that hopefully some of you are also going to write unit tests when you're working with JavaScript. And JavaScript does not have types. Yeah, it has types, but it's not strongly typed. So you don't get help from the compiler to solve your type errors, which means that it makes sense to sometimes test the type of the return value. But this is a very simple test to write. And we usually write such test cases when we don't know the expected value, when we cannot know it. Perhaps this expected value is something that changes day from day. Like during the last lectures, where I showed you the ambiguous test cases, where students were looking at the screen and they were examining the date, and the date differed. So we have different strings every day. So let's just compare that we get a string, because it's different every day, right? Okay, so I think we need a break now. So let's take 15 minutes and let's meet again 11:17. Write in the chat if you could follow me during this lecture, if it was too fast or too slow, or if it's okay. So thank you very much for listening, and let's meet again 11:17. Okay, so we're gonna start again. My estimation on the stream, it's gonna be 11:17 when we start. So there are many different types of unit test framework, and I just put an X in front of those because at some point at least they were all called like JUnit, NUnit, PHP unit, and stuff like that. And PyUnit and JS unit and stuff like that. But there are a number of different ones of these, and new ones comes up, and they have different properties and stuff like that. So, and I mean, these are also going to change in the future. And I mean, look at their capabilities for your preferred or the language that you have to work with, and then you select one of those. In many cases, we are not able to select because someone has already selected for us, right? And then we just live with it. So this part is it's sort of a generalized thing with these. So what do they contain, these frameworks? So and this is a bit different in different ones, right? So but in JUnit, we've already seen that we have a test class, and within the test class we have asserts. So when we look at the test case like this, we have a test class, and the test class is normally, I would say, one test for each class. So one test class for each system under test class, so to speak. So I have my math, and then I have my math, and I call this my math JUnit just to show that it was JUnit, but I usually just name it like this. We could, yeah, we're gonna get an error message here, but it's because I didn't rename the file and stuff like that. But that is normally the general convention. I've not really come up with other kinds of information that I want to say. I want to say these are the tests for this particular class. I mean, these usually are in, we could place them in a package, right? So we could have, and we could have many test classes that are testing the same unit. So I'm just gonna rename that so that next year I'm not gonna have a problem with that. So, but we have test classes with test methods. Each method is a test case, and then we have asserts. And you've also seen that I tend to do my own asserts in order to save code, to get more dry code. No, yeah, less dry code. More, less, I don't know. Don't repeat yourself. Right? So, and then we have test suites. And a test suite is a collection of test cases. I mean, it could be a collection of test classes. And usually for JUnit, it always is, right? So we have a test suite, which is a collection of test cases that normally run together. So we can divide our, our tests into different suites. And one reason for doing that is to run faster. So you can have one suite with that are super fast to run, or one suite for a particular component of the program. So if you're working in the front end, perhaps you have a test suite that is only concerned with the front end. So if you change the front end, you don't need to run the back end tests in order to speed up the test. If we could, we would run every test, right? Because we could have dependencies from the front end to the back end, and we want to make sure that we didn't destroy anything, right? So it made sense that if we could, we would run more test cases. Sometimes there are so many test cases, and I know Google, when in the Chromium project, they have I don't know, 100,000 test cases, and it takes forever to run, right? And then they have a test suite of their most critical test cases that the developer runs so fast, right? I think there was 1,000 test cases, but this was 10 years ago, so it could, or I don't know how many years ago, but when I looked last time, it was a long time ago. So this could have changed, right? But they had a test suite of the fast test cases, and you run those, every time you compile. And then they had a more complicated test suite of the slow test cases, or all different parts that run before you do the next step in their process, right? But we could have a test suite, and I usually have like a unit test suite which contains unit tests, and then I have an integration test suite that contains integration tests, and then I have a system test suite that contains system tests. But only the first one was concerning unit tests, right? So in a unit test, I just test my methods, and then with the integration test suite, I test things that they work together, and then I have my system tests. But all of these, I run them as JUnit tests. And unit framework usually have a way of running the tests, and you know that you can run your test with Gradle, but you can also run them in Visual Studio Code, and you've seen the plugin. And make sure that you run the plugin in Visual Studio Code. Just to contrast, the screenshot is from an old version of Eclipse, I think. And this is the way it looks like when you run your test suites in Eclipse, right? So you can see the succeeding test suites, or the succeeding test classes, and then you have the failing test class. I think the red one is when you have an expected value and an actual value that doesn't matches, and then the blue one is when you get some error, or I divide by 0, for instance. So they differentiate between these. So they differentiate with errors and failures. We use errors only for the error state, or for the error that a programmer does in this course, just to make sure that you get the vocabulary right for the exam. Okay, so we can run the tests perhaps several different ways. We can rerun the tests, and we perhaps only rerun one test. So if I could right-click on this one, I could rerun that. And we have that functionality here where we have the run tests only for one test. So I can speed debug just one test at a time if I want to, or just a test for lecture test. I can run those, or I run all the tests in this map. Yeah, folder, but it was called map in the template project that you got. So we can get a test report. The test reports can be different types, right? This is sort of a test report in the screenshot, and in Visual Studio Code, you also this is a test report, right? But we can also get a test report that we can integrate into a pipeline or a build pipeline. So, for instance, if we have a build pipeline on GitHub or on GitLab, which is a part of our release process, then we can, every time we do a merge request, the test is run on the new code. If we have a succeeding test, we progress to the next step of the pipeline, and perhaps we, release the code to the public. Perhaps we have other parts. If we have a test case, maybe a test report is generated. It's perhaps emailed to the developers so that they can, fix these problems. Sometimes it showed on GitLab. Sometimes it showed on, some other way, right? So the test report could be many different things. If you look at JUnit, there are many different ways of generating these reports. We could get HTML files, perhaps, and stuff like that. Unit testing frameworks usually have some mechanisms of code coverage also. Sometimes the coverage is a separate tool. So it's not a part of, JUnit. It could be a part of the coverage tool instead. So, I mean, this depends on the developers of these frameworks. They decide what to include and not to include. And this is what I meant with that I'm doing a generalization of these. So if you take a testing framework, they don't always contain code coverage. And they don't always include mocking either. So we're going to dive deeper into mocking. And during this lecture, we're not going to go so deep into it. I'm just going to name it really what it is, or sort of name the problem that it solves. So for JUnit, I don't think there is a mocking thing in it, but I have not looked into the Jupyter version of the JUnit, so I don't know. But previously, I used a separate framework for mocking. Mocking is to replace a difficult dependency, but also to test behavior, which is also a future lecture. So instead of testing what a method returns, we can test its behavior. We ask it, what does it do? So actually testing that it calls, for instance, methods in a specific order, for instance. So we can say that, oh, when this method was called, it never returned anything. So we never tested the return value, but it did call the database function. So we can test its behavior. So we're testing that it called the database function. And we could do that by mocking. So, and this next part, yeah, so I'm going to do a lot of talking here. And the slide is gray. So you're going to fall apart and you feel your eyelids are closing. Okay, so the next part is actually, I want you to, during the assignments, to experience some of these problems. And I want you to reflect on these problems, because I think that when you experience these problems, perhaps you just feel a bit of tension, or you experience a question. But these questions that you experience are important. And these frustrations that you experience are also important. So I want you to reflect on that. And I want you to catch that. And I want you, have a piece of paper next to the computer and just write, why can't I test this code? Or whatever you feel. And then you turn that into a more, answerable question. How should I test code that does not return anything, for instance, which is a super relevant question. And I say that I want you to experience these difficulties because this is the way that you learn. And especially if you do not just the first assignment, but the second part of the first assignment. Okay, so the first thing is that it's not always easy to run code. Sounds stupid, but you have an if statement in the code, and perhaps you cannot enter that if statement because it only happens for specific cases. And perhaps you cannot input those specific cases. So let's say like this. Let's say that you've written code that opens up a file. And if this file is empty, we get into the if statement, right? But let's say that this file is also supplied with the system. So it's in your path. And when you run your code, it always opens the file, and the file has always code in it. So in order for you to write a unit test or a JUnit test to do this, you actually need to remove all content of that file. Perhaps it's a configuration file before you run the JUnit test. And then after you run the JUnit test, you have another test that requires this file, right? So we have a difficult piece of code, an if statement that we cannot go into. But this if statement is still needed because if this file was empty, we should throw an error, right? We should tell someone to fill that file with the configuration things. So we can have unreachable code. And this was just one example. And, we can solve this problem, but we can still have, when we don't think about testing, when we don't think about controllability, we introduce these kinds of problems. You're going to have if statement that is never going to go into. Normally, I would say that, we say that 20% of the code runs 80% of the time. And perhaps 10% of the code is never run. So we just write code that never runs. In some cases, we have, let's say we have both, I don't know the English word for this. But the Swedish thing is, maybe someone can write in the chat what the English proverb is for this, that if you have hängslen och bälte, liksom, we have double security. So we can have an if statement that checks that, the string is this long, and then somewhere inside the code that is run there, we check it again. And the else part of that is never going to run either. So we can have unreachable code, we can have code that we can't really replace for some reason, so we never run it, so we can never test it. which means that if we measure success in testing as all code has been tested, that can be unfair, because some code never runs, because we cannot produce that situation. We can never really create that input. Okay, when I say never, I'm just sort of provoking, right? Because I want you to feel that, oh, I can run all my code because I'm an excellent programmer, and you are, and you're on your way to become that. So the different reasons that I've experienced for unreachable code are the following. Is we could have complex code. It does too much. And we can solve that problem by writing clean code. And there is a good book that is called Clean Code that you can read in order to learn this. So I'm actually going to promote that book. For some students, I know they have read it. For the rest of the students, buy that book or find a PDF. It's a really good book. Okay, we could have static code. So for instance, we have a static main method. We can have static asserts, for instance. We can have static code that we create out of convenience, like, oh, I use the database object everywhere. So I create a static access, so I don't need to send the database object to all my methods. If you think like that, you're actually creating code that is going to become harder to test. Because when we're testing stuff, we want to replace dependencies. And if we are statically dependent within the code, dependent on, for instance, the database class, a specific database class, we cannot replace that. So you should not write the word static more than once in your program, and that is when you use the static main. So just forget about that word. Students usually hug on to static and think that this is a really good solution, because suddenly they don't need to learn object-oriented programming. But just unhug that thing, realize that that balloon is going to burst at some point, and just don't write static again, except for your main method. So I think, and there is also a static that is not called static, or which is called singleton pattern, that you're probably going to learn in another course or so. And you just forget about that pattern also. Instead, you're going to use dependency injection. And you're actually going to send the database into every object that needs the database. And you're going to inject that. Okay, so enough of lecturing of things I should not lecture you about, which is your responsibility. But forget about static. And then error handling. So we can have error handling that we cannot produce this error during tests. So it could still happen, in the wild, but we cannot really produce this. It's usually because we have a static dependency or so. We can create error handling that never happens. Sometimes we are forced to do that. So for instance, Java forces you to handle exceptions, even if the exception cannot happen. So you might have a catch statement that are unreachable code. Yeah. So you should use exceptions and mocking and try to avoid these constructions. There are types of coverage also. We're not going into coverage so yet. I've just said that we can measure how much of the code has been run. There are ways or coverage types that sort of you cannot get 100% coverage for. Yeah, so think about the new operator also. When we create objects, if I within a class write new and then the class name of the object I want to create, you cannot replace that class. So you have a dependency that is statically sort of written by the new word and the name of the class, so you cannot change that when you run that code within test. So if you want to replace that dependency, you cannot use the new keyword anymore, or you should use it only within your factory classes. So you create a class that is responsible for creating other objects, and you send an object of that class into your, which is called the factory pattern, which is a good pattern. And it's actually good for more things than that. But this creates easier to test code. So hopefully you're going to learn the factory pattern during assignment 1, part 2. Okay, we've also already talked about dependencies, and dependencies are problematic. So let's talk about the easy to understand ones. Like if I communicate with a database in my code, and I test the code that communicates with the database, I will get slow tests because databases are slow. They are, comparatively slow comparing to just running code. So if I open a file, databases are essentially files, right? So if I open a file, that takes 100 times slower than just running code, than just running an if statement. So if I am dependent on a database, it means my test becomes slow. So I should not be dependent on the database itself. I should be dependent on an interface that is the database. And then I can replace the database during test with something that is fast, which is called a muck. So I create a fake database that is super fast, that responds in a predictable way, independent of state, and then I can test my code without that. If I have state, and this state is created by running a lot of code, then that is also hard to control. So for instance, if I need to run a lot of code during a lot of circumstances, I get a lot of inputs, a lot of things I need to change. And then that is also difficult. So mocking will solve that also. If I don't have any return values, I'm just calling methods. Perhaps I'm just talking to an API. Perhaps I'm just, writing things to the console, and I'm not returning anything. That becomes hard to test also. Or it's hard to test because if I don't have any way of mocking it. So if you're in your JavaScript, you write to the console log, or if you're in your Java, your system out print line, you need to, handle that some way. It's possible to do it still, at least in Java, I know how to do it. You just, replace the system out with something custom, and then you manipulate that, and you check your outputs through looking what was written to the output stream. But we've already talked about code that writes to a database. How am I going to know that it was correct? I might need to check the database. Or I mock the database and I check that stuff was written in the correct way to the database. Finally, there are probably more of these. But these are the ones that just came to my mind according to my experience. But I want you to participate in this, and I want you to be reflective when you write your code. So if you find stuff, this is hard to test. For instance, stuff that students usually find during this is private methods. How do I test my private methods? And then you ask that question in the Slack, and we discuss it, and we try to find ways of testing this code. And we discuss the pros of this and the cons of this. How many lines of code was it to write this complicated test? This is super interesting. We should share that with each other, right? So reflect, write it in the Slack chat. Perhaps you anonymize it a little bit so it's not, the solution to the assignment, right? But I'm super happy with that kind of questions. So don't stress about it. Don't think that you're stupid. You're learning. You should ask questions as students. You should be allowed to do that. And I love it when you do that, right? Okay, the final thing that I found was indeterministic code. And this means that code that does not work the same the next time you run it. For instance, you have an instance of random in it, and you return a random string. How do you test a random string? Yeah, I'm just going to check that it's a string that is returned. And we've already talked about that. That was a weak test. So if if the return value is dependent on a random thing or the time, then you need to replace that difficult dependency, the random or the time. So you mock that, and you're dependent on the mock, and then you can, replace that. I'm going to go deeper into mocking. So right now, just think of difficult things or dependencies can be mocked, and we can replace those with something that is predictable, and that sort of saves everything. So I think I'm getting tired, and you're probably also going to get tired. So I think I'm just going to talk a little bit about slow tests, and then we're done for today. So when I run my test suite, I like them to be super fast. I like them to be like less than 10 seconds. I think over 10 seconds, we start, to do other things while we wait. For instance, when I had slow test suites, I started coding again. The test suites were running in the background, and I started coding again. But that was problematic because the debug session that should happen was not with the same code anymore when the test eventually succeeded. So I met this German car manufacturer guy that was responsible for testing once, and he told me that their test suite, fully automated test suite, took 2 weeks of runtime. 2 weeks of running them. And this was not, running on some slow computer. These were many computers. This was, they had great resources. A big German car manufacturer. So one of the bigger German, and they had this problem. And the problem that behind that, because I asked, don't you mock your databases? And they said, no, we cannot do that. We need to run tests that are actually of the entire system also. So these were not unit tests anymore, right? Because they tested the system. So each of their tests needed a database to be set up in a specific way, right? So we need to have this and this state in the database in order to run it. So it had this complicated state problem that we talked about here. And it had the dependency to the database, which is also really slow. So my suggestion to them would be, okay, maybe you need to create your fast test suite that only takes a number of seconds, that is not dependent on databases, and then you keep your, the one that you need to do for security reasons, because we don't want our car to decide that a left turn, 90-degree turn when you're going 110 on the freeway is a good idea. We still want to have these system tests, but imagine that if you start to collect slow test cases, your entire test suite is going to be slower and slower and slower, because you're going to just add more of these. And when you start to add one kind of test, you copy paste that test. And then you add another one, and the runtime is doubled and tripled and quadrupled and stuff like that. So imagine waiting 2 weeks for a test result, and then you start debugging. Of course, during these 2 weeks, you did stuff, right? You continued to develop the software. And then if a test failed, then you need to run this again. Super frustrating, right? So this reminds me of my mother, because my mother was programming before I was born. And at that time, there were different roles of programmers. So the programmer was actually someone that written the program on paper. And then you had another person that entered this program into a computer readable form. And then my mother came in, because she was step number 3, which was to create this, this savable thing that you can rerun. They had these cards that with holes in them, which is essentially their storage. And she was, part of that process as a student. So when you decided that, oh, I need an if statement here, it could take, a week before you ran that code. When we are so used to get feedback and to run stuff directly, and we are dependent on that feedback, and it's important for us. So think about this feedback as super important, and you want to make it super fast for you to get that feedback so you can get it all the time. And be wary of things that take time when it comes to tests. So, and I think I'm going to leave you with that, and we're going to continue tomorrow. I think it's in the afternoon, right? I've not checked the schedule. So thank you for today. Hopefully this was useful to you, and we're starting to get closer to the things that you do in your assignment. Okay, thank you very much.